Okay, so to work on the second assignment, you need to open a different example. So for that, go to File and click on Open Sample Project. And in category, select VSM for AVR, and in subcategory, select Arduino. And here you will find the fourth example, Arduino and RGB common cathode LED. Okay, so double click on it to open it. Then go in schematic capture. You can see we have RGB LED, one oscilloscope, virtual terminal, and this 13th pin LED, which is inbuilt on the Arduino. So we will use this 13th pin LED, and we will generate the square wave in this pin only. Okay, so you need to alter the source code for that. So first of all, we need to declare that 13 pin as output. So for that, right. Okay, so now this command will set that pin as output, and whatever is written in the void loop, remove all. And I am taking an example of generating a square wave with on time of 200 millisecond and off time of 200 millisecond. Okay, so for that, I'm driving it by this statement. I'm driving it high and giving a delay of 200 milliseconds, and then I will drive it low. Delay of 200 milliseconds. Okay. Now, after writing your code, you need to compile it. So in Arduino, it was verify or compile option. But in Proteaus, we have build option. So go to build and click on build project. So this will compile your source code. So here it is showing compiled successfully. Okay. Now go to schematic capture and run the simulation. Go to schematic, sorry, go to this uh, button and press it to run the simulation. You can see the LED is blinking. Okay. So now we can see the LED is blinking, but we don't know what is the exact time period and how to check the wave which is generated on the pin. So for that, we will use this oscilloscope. So this connect this 13th pin to the channel D of this oscilloscope. So for that, left click on this D channel, and for that first you need to stop the simulation and left click on this D pin of the oscilloscope and keep pressing it and drag it and uh, connect it to the 13th pin and release the left button. So it should connect the 13th pin to the D channel of the oscilloscope. Now run the simulation again. So it now this 13th pin is connected to this D channel of the oscilloscope. Now we need to check whether the square wave is generating or not. So for that you need to open the oscilloscope. So go to debug and click on oscilloscope. So here you can see we have 4 channels, but we have connected our output to the channel D. So channel D is green, so it is showing here. Okay, but it is the skills are not calibrated. Okay, so for that, first you need to slide this slider to the DC because we are generating DC signal. Okay, DC signal means zeros and ones. Okay, and then you need to change the voltage scale. So I am setting it to 1, so it will be 1 volt per division. Okay, and the horizontal scale to 200 milliseconds. So you can see it is yeah, it is generating a square wave. So this is how you can check your on time and off time of square wave. Here we have generated a symmetric square wave, which means sorry, the on time and off time are same. So if you want to alter it, you can do it just by increasing or decreasing the delay. First, you need to stop this. First, you need to stop the simulation, and then alter the source code. So I am increasing the on time to 500 milliseconds, and the off time is 200 milliseconds only. Okay, now I will build it once again, and I will run the simulation. Okay, now to open the oscilloscope, go to debug and then digital oscilloscope. Okay, so you can see the on time is increased and off time is same. So this is how you simulate your outputs.